I'm going to share with you my story of the adventures I've had at sea over the last 8 years and talk a little bit about plastic as well, because that is the ocean issue that I've ended up tackling the most. But most of all, I want to kind of talk about that journey that took me from an architecture student to now sailing around the world on these projects that I'm passionate about and that take me to places like the Arctic for my daily bath. Not really what I had in mind when I trained as an architect 10 years ago. So the question is, how did that all happen? And for me, it began with a passion for sustainability. And when I had the opportunity to write my dissertation at architecture school on anything I wanted, I thought, I'm going to go to an eco-city in Shanghai, a place that I'd never been to before and knew nothing about. But I thought, I can't go to a zero carbon city by plane and clock up a huge carbon footprint along the way. So I'm going to have to get there some other way, and ended up having this amazing journey by train, camel and horse across Europe, Russia, Mongolia, down through China, and eventually 6 weeks later getting to Shanghai. But it was that journey that changed everything for me, because along the way I experienced these amazing transitions, that subtle change in climate and culture and landscape, and most of all the people who you meet when you're traveling slowly. And I decided that I didn't want to get on a plane ever again. And so the following year I graduated with my architecture degree and lined up my first job as an architect, this time in Australia. So I started looking at the map, England to Australia, 14,000 miles, no aeroplanes. How was I going to get there? And so I started typing into Google how to hitchhike around the world, and suddenly this just popped up. This boat is called Earth Race. It holds the round the world speed record. It went around the world in just 60 days. But the cool thing, it runs on 100% biodiesel. So fuel that's come from all sorts of renewable sources, waste cooking oils, waste animal fats. And they had just broken this record, but now they wanted to go around the world for a second time. This time to do a promotional tour, to visit 120 cities, to talk at schools, universities, meet with the media, and talk about biofuel. So I applied for a job on board this boat, and the skipper said, come and meet us for the weekend. So I showed up in Brighton for the weekend and didn't end up going home for another 923 days. So this boat, it was my ticket to Australia, but it actually ended up being the trigger to an entirely new career that I was never expecting. And so we set off and we had the most amazing journey. I learned to wakeboard in the middle of the Atlantic Ocean. We went through the Panama Canal in a thunderstorm, and we crossed the Pacific, stopping in the Galapagos and getting welcomed into these amazing Polynesian communities along the way. But then there were the things that I was never expecting to see on this trip around the world. And one was being woken up in the middle of the night by a thud on the hull of our boat, and coming up on deck to find that we were surrounded by plastic in the water. We were over 1,000 miles from nearest land. The closest people to us were in the space station in orbit above our heads. And yet there was this evidence of human life and waste in the water all around us. We'd then stop at these small islands and we'd find the locals were struggling to catch fish because the commercial fishing vessels had emptied their waters of the fish they knew how to catch. And they were struggling to grow food in the ground because that sea level rise had caused their soil to become too salty. And so the knock-on effect of this was a new reliance on packaged, imported food that all got shipped in from overseas, all wrapped up in this new weird material, this plastic. In between these islands, we had days, weeks of this open blue ocean, and we'd sit on the roof of Earth Race and we would stare out at that perfect blue sea. And it was up here for me that things started to change, because when you're at sea, you react to the changes in the environment around you. If the waves change direction or the wind picks up, you have to respond. You have to shift your course, and often your life depends on that response. And it was at this point that I realized that I too needed to shift my own course, my career, and start responding to some of what I'd been seeing in these places. And in fact, not go and build more buildings as an architect, but try and do something to tackle these problems. So I ended up going back to this tiny little island, one of the remote outer islands of Tonga in the South Pacific. And while it looks like paradise from here, white sandy beaches and turquoise ocean, on the ground it really is a different story. So these communities are struggling now with a whole reliance on imported food, but no system in their society to deal with that waste, with that plastic. And so it ends up getting thrown on the beach, in the ocean, and also burnt. And it was that burning of plastic, that toxic smell, that kept getting at my nose, and I started to learn more about what was that chemical that I was smelling. And I learned about these chemicals, dioxins, that are produced through incomplete combustion, which is what's going on here, and that they lead to cancer, and that they're endocrine disruptors that mimic our hormones and really are chemicals that we and these kids for sure don't want inside our bodies. And so for me, this became my first mission, age 22, I think at the time, was to attempt to eliminate the burning of plastic across these two small islands in the South Pacific. So I started meeting with the locals, working in the schools, trying to find out more about the problem. And on learning the Tongan language, I realized that there wasn't a word for rubbish or for bin, and that concept of throwing something away in a controlled manner didn't exist in their culture, because up until really recently, it hadn't needed to. A banana peel or a coconut husk could happily be thrown on the ground with no consequence. So it wasn't just infrastructure that was needed in these islands, but actually a whole new way of thinking about this new weird material. So we spent 6 months working across all the schools, simply teaching about the difference between organic and inorganic materials. And at the end, we culminated in an enormous cleanup event. We had 3,000 people, which was 3/4 of the whole population, come together, and we picked up 56 tons of rubbish in 5 hours. This rubbish then took us a couple of weeks to clean and sort and package into 3,000 rubbish sacks, so it could get loaded into 8 shipping containers to be taken away, some that could be recycled and the rest to a nearby landfill. So this time on Tonga was another really transformative time for me. But I was not only dealing with the waste from the local community, I was also walking along the beach each morning and seeing plastic washing up from somewhere really far away. And so this started probing more questions. Where is that plastic coming from? And why is it ending up on this little beach in Tonga? At the time, a lot of the plastics experts were based in California. And so that became the next place I was to head on my plastics quest. And off I went, this time by freighter ship, back across the Pacific Ocean to get to California. And that's where I met this guy, Captain Charles Moore. He'd first discovered this issue of plastic in the North Pacific Ocean about 25 years ago and has been looking at it ever since. But at this time, I still couldn't quite get my head around, why was there all this plastic in the ocean in the first place? Where was it actually coming from? So I started to learn a little more about plastic itself. This image here, 60,000 plastic bags. Does anyone know or would like to guess, how often do we use 60,000 plastic bags in the world?
1 second.
It's every 3 seconds. We're using 60,000 bags, and they get used once, maybe twice, probably 3 times at best, and then they're thrown away. And really that's the thing about plastic, is it's a material that's designed to last forever and ever, and we go and make things like bags and bottles that are designed to be used once and then thrown away. And it really is that mismatch of material science and product design that puts us in the situation of having so much waste plastic that no longer has any use or any value. But then I thought, no problem, surely we can just recycle all that plastic, we can just turn it back into new things. But it turns out only around 10% of all the plastic we use actually gets recycled. And that number's so low because plastic is a word that we give to hundreds of different materials. They all have different properties. They're stretchy, hard, coloured, clear. And to give them those properties, they need different chemical structures and additives. So if you want to recycle this lot, you've got to clean it, you've got to separate it all out, you've got to pull objects apart. You've got something like a toothbrush, which has got maybe 3 or 4 different types of plastic, all stuck together in one object. And it's so time-consuming and expensive to pull that all apart and recycle it. And unfortunately, it's much cheaper to take more oil from the ground, make new plastic, and throw the old stuff away. So all this plastic, no place to go, a lot of it ends up going down drains, down streams, rivers, and ultimately everything runs downhill to the ocean. So this is Los Angeles, a city that has a great waste management system, and yet this much still escapes. And then you've got somewhere like Indonesia, where the only option is to put your waste in the canal that runs through every village, this taken just half a mile upstream from the ocean. And the question is then, what happens? Where does all this waste go? Because we know that 80% of what we're finding out there comes from places like this. It's coming from these point sources on land. And when it gets out into the ocean, it then meets these ocean currents. So because our planet is spinning, it creates these great big rotating system of currents, the Coriolis effect, clockwise in the northern hemisphere and anti-clockwise in the south. And in the middle of that great big rotating system of currents, it's really calm. And anything, whether it's a piece of seaweed, a piece of algae, or a piece of plastic, wants to move towards the center of this hotspot that's become known as a gyre. And that's where all this plastic accumulates. And so there's actually 5 of these hotspots around the world in the centers of each of the oceans. And so these 5 hotspots became known as the 5 subtropical oceanic gyres. Now, at this point, when this hypothetical study was published, only Captain Charles Moore had been to the North Pacific to survey what was there, and no one had been to the other 4. So, as you can imagine, this became the next mission, to go to those other 4 gyres and find out what was there. Was there any plastic? And if so, how much? And ultimately, was there anything we could do about it? So that's where Sea Dragon comes in, this 72-foot sailing expedition yacht designed to race around the world. We got enough funds together to actually buy her in 2009 and set up an expedition company to take people out to sea to get data and footage and findings of what was going on. And so for the last 8 years, Sea Dragon has been sailing with a different team of 14 people every couple of weeks to go out there doing this important work. And when we first got out there to the middle of these gyres, we'd get our nets out and we'd start spotting bits of plastic in the water. We'd put the nets in and we'd bring them up on board, and we find everything that you can think of that's made of plastic on land, whether it's a bottle top or a cigarette lighter or a washing basket or a welly boot or a rugby player's gum shield. You know, it's all floating around out there in these gyres. But what surprised us is at the end of one day of hauling this plastic in, this is all we found. Now there's 8 million tons going into our ocean every year. Where was it all going? And it turns out it's actually just breaking down, too small for us to see with our eyes on the surface. The big pieces break down from the UV rays of the sun into these smaller fragments that we call microplastics. But the key here is it's not biodegrading. It's not going back into the natural circle of life. It's simply getting smaller, harder to see, and much harder to clean up. So to monitor this, we built these trawls that fly along the surface of the water, along the side of their boat, and catch anything in their path. And when we pull that trawl up on board and we turn the sock inside out, this is what we find. Hundreds of these tiny little fragments of plastic, smaller than your little fingernail, and the same size as the zooplankton and much of that organic matter that makes up the surface layer of the ocean. And so we spent the next 2 years crisscrossing our way all around the globe, and really wherever we went, whether it was down in the South Pacific, in the North Atlantic, the Indian Ocean, and even on a trip through the Northwest Passage in the Arctic, through a stretch of our ocean that's only water for a few weeks of the year because it's frozen for the rest. And we were still finding these small fragments of plastics and microfibers there as well. And we realized that it's not contained to the gyres, it's actually this fine soup that varies in concentrations across the whole of our ocean, which covers 70% of our planet. When we get those samples back on board, we then have to analyse them, looking down the microscope, and work out what's plastic and what's plankton. It turns out here, these two fragments are actually plastic. Almost impossible to tell looking down a microscope. How is a fish supposed to figure out what to have for lunch when he's looking at the surface of the water? And so then we start to find things like this fish that actually had plastic inside his stomach that he'd mistaken for food and ended up eating. So at this point, the conversation changed a little bit, because at first we were interested in the physical presence of plastic in the ocean, but then we realized if plastic is getting into fish, into the food chain, the same food chain that we're at the top of, then what might that mean for us chemically? And so at this point, myself and Lucy Gilliam, in the striped top just over there, set up a new project called X Expedition, which is a series of all women's voyages, hence that double X. And it's all about making that connection between plastics and toxics and female health. Because the more I learned about these chemicals, these endocrine disruptors that mimic our hormones, the more I realized how they actually affect puberty, fertility, reproduction, and really us women and our ability to reproduce. And actually the only way we get rid of these chemicals is by passing them on to our young through both giving birth and through breastfeeding. And so we both felt that, you know, this was worthy of a whole new entity to start tackling and shedding some light on this very crucial women's health issue, but at the same time supporting women in sport and adventure and going out and putting together these all-female teams and not doing the easiest route, but the hardest one. Crossing the North Atlantic was our opening voyage from Lanzarote across to Martinique. We had a horrible first 5 days, I think we'd sum it up, of storms and just generally really challenging. The girls just holding each other's hair back as they vomited over the side for the first 5 days. But it was amazing. It brought us all together. And after 5 days, the wind spun around in the right direction and the sun came out. And we spent the next couple of weeks sailing downwind, making a documentary, collecting all of our samples, and building what, you know, is now a few years later become this kind of international entity. And coupled with the work at sea, we're also testing ourselves for the same chemicals that we're finding as pollutants out there. And this has been a study in partnership with the United Nations Environment Programme, and we chose these 35 chemicals to test ourselves for. And in the first study, we found 29 of these banned toxic chemicals inside our bodies. So we actually realized that this was something, you know, that we really needed to work on, because while the levels of chemicals we have inside us at the moment aren't alarmingly high, it's evidence that we are moving in a direction that we really do not want to go any further. So we completed that trip, and this moment of getting to that finish line, I remember it should have been one where we thought, yes, we've done it. But actually, having been out there, seen everything, the conversations we had, that moment we reached land, it felt like day one. We had all of these dreams and ideas of what we were going to go on and do next to solve it, because the more time I spend at sea, the more I realise that the solutions, they all start here on land, because that really is where the problem begins. And so X-Expedition has now completed many more voyages over the last few years, the Atlantic, across the equator, the mouth of the Amazon, around the Caribbean, and very excitingly, this summer, ta-da! We are going to be circumnavigating the UK. So we're bringing this very global issue that we see all over the world actually right home here, and we're going to do the first continuous study of plastic pollution and toxics in UK waters, visiting all the capital cities along the way. So lots of really exciting stuff happening this summer. And that's us and our website if you'd like to know more and get involved. Thank you very much.